In most cases, a neutral wire is not required for the quartz lamp on a 240-volt low-bay fixture. Quartz restrike lamps, also known as high-intensity discharge lamps, do not require a neutral wire because they operate using an arc discharge between two electrodes. The ballast, which is connected to the power supply, provides the high voltage necessary to ignite the arc. Once the arc is established, the ballast limits the current, maintaining a stable light output. For 240-volt low-bay fixtures with quartz restrike lamps, the wiring typically consists of two live conductors, often labeled as L1 and L2, and a ground wire. The power supply provides 240 volts between the live conductors, which is sufficient for the operation of both the ballast and the quartz lamp. However, there may be some exceptions to this rule. Some specific models of low-bay fixtures or quartz lamps may require a neutral wire for proper operation. Always refer to the manufacturer's instructions or specifications for the specific fixture you are installing to determine if a neutral wire is required. High-intensity discharge, or HID, lamps encompass various types of lamps that produce light by means of an electric arc between electrodes through a gas. Common types of HID lamps include mercury vapor, metal halide, high-pressure sodium, and ceramic metal halide lamps. Quartz restrike lamps are often a feature integrated into metal halide or other HID lighting systems to provide immediate illumination during power outages or voltage dips. Here is a detailed breakdown of HID lamps. Mercury vapor lamps were one of the earliest types of HID lamps developed. They produce a bluish-green light and are typically used in street lighting, industrial lighting, and security lighting. Mercury vapor lamps are gradually being replaced by more energy-efficient options due to their lower efficacy and the presence of mercury. Metal halide lamps offer improved color rendering and higher efficacy compared to mercury vapor lamps. They contain metal halide salts in addition to mercury, which enhances the color output and light intensity. Metal halide lamps are widely used in sports stadiums, warehouses, retail spaces, and outdoor lighting applications. High-pressure sodium lamps are known for their high efficacy and long lifespan. They emit a yellowish-orange light and are commonly used in street lighting, parking lots, and industrial facilities. While their color rendering is not as good as metal halide lamps, their energy efficiency makes them a popular choice for large area lighting. Ceramic metal halide lamps are a more recent development in HID lighting technology. They use a ceramic arc tube instead of a quartz arc tube, which allows for higher operating temperatures and improved color stability. Ceramic metal halide lamps offer excellent color rendering, high efficacy, and long lifespan, making them suitable for retail displays, architectural lighting, and other applications where color quality is important. Quartz restrike lamps are auxiliary lighting components designed to provide instant illumination when the main HID lamp experiences a power interruption or voltage sag. When a momentary power loss occurs, HID lamps typically take several minutes to cool down and restart. During this restrike period, the area remains dark, which can pose safety and security risks. Quartz restrike lamps address this issue by providing immediate light output until the main HID lamp restarts. They are typically small halogen or incandescent lamps integrated within the HID fixture. These lamps are wired to an independent power source and are activated automatically when the main HID lamp shuts off. Quartz restrike lamps offer several benefits. Firstly, they enhance safety by providing continuous illumination during power interruptions, reducing the risk of accidents and injuries. Secondly, they improve security by preventing periods of darkness that could be exploited by intruders. Thirdly, they minimize disruption to operations by ensuring that lighting is immediately available, allowing work to continue without delay. The installation and wiring of low-bay fixtures with quartz restrike lamps typically involve connecting the fixture to a 240-volt power supply. The 240-volt supply is connected to the ballast, which regulates the voltage and current to the HID lamp. The quartz restrike lamp is wired to a separate circuit that provides power when the main HID lamp is not operating. Grounding is essential for safety. The fixture should be properly grounded to protect against electrical shock. The grounding wire connects the metal housing of the fixture to the electrical grounding system, providing a path for fault current to flow back to the source in the event of a short circuit. This helps to trip the circuit breaker or fuse, disconnecting the power and preventing electrical hazards. As previously stated, in most cases a neutral wire is not required for the operation of the quartz restrike lamp itself. The ballast and the HID lamp it powers typically only require two hot wires alone, an L2 and a ground wire. The 240 volts is supplied between the two hot wires. However, the specific wiring requirements can vary depending on the manufacturer and model of the low bay fixture. It is crucial to consult the manufacturer's instructions and wiring diagrams to ensure correct installation. Some fixtures may have additional components or features that require a neutral connection. If the instructions call for a neutral wire, it must be connected as specified. Incorrect wiring can lead to malfunction, damage to the fixture, or even electrical hazards. While a neutral wire may not be required for the quartz restrike lamp, it is important to ensure that the overall electrical installation complies with local electrical codes and regulations. These codes specify the requirements for wiring, grounding, and overcurrent protection to ensure the safety of people and property. An electrician should always be consulted to ensure compliance with all applicable codes. Understanding ballast is crucial for understanding how HID lamps operate without the neutral wire. A ballast is an electrical device used to regulate the current and voltage to HID lamps. HID lamps require a ballast to start and operate properly because they have a negative resistance characteristic. This means that as the current through the lamp increases, the voltage across it decreases, which can lead to a runaway current and damage the lamp. The ballast limits the current to prevent this from happening and provides the necessary voltage to start the lamp. There are two main types of ballasts: magnetic ballasts and electronic ballasts. Magnetic ballasts are older technology and use a transformer and other components to regulate the current and voltage. They are less energy efficient and heavy than electronic ballasts, but are also less expensive. Electronic ballasts use electronic circuitry to regulate the current and voltage. They are more energy efficient, lighter, and offer better performance than magnetic ballasts. Electronic ballasts also typically have features such as automatic shut-off in case of lamp failure and dimming capabilities. The ballast provides the high voltage necessary to initiate the arc within the HID lamp. This starting voltage can be several thousand volts, depending on the type of lamp. Once the arc is established, the ballast reduces the voltage to the operating voltage of the lamp and regulates the current to maintain a stable light output. The ballast is designed to operate with a specific type and wattage of HID lamp. Using the wrong ballast can damage the lamp or the ballast and can also create a safety hazard. Therefore, it is important to use the correct ballast for the lamp being used. The absence of a neutral wire in many 240-volt low-bay fixtures is due to the design of the power distribution system and the way the ballast operates. In a 240-volt system, power is supplied through two hot wires, each carrying 120 volts with a 180-degree phase difference. The ballast is connected between these two hot wires, and it draws power from both of them. The current flows from one hot wire through the ballast in the lamp and then back to the other hot wire, completing the circuit. Since the ballast is connected directly between the two hot wires, there is no need for a neutral wire to provide a return path for the current. The ground wire is still required for safety, as it provides a path for fault current to flow back to the source in the event of a short circuit. In summary, while most 240-volt low-bay fixtures with quartz restrike lamps do not require a neutral wire due to the arc discharge operation and ballast design, it is crucial to consult the manufacturer's instructions of the specific fixture being installed. The instructions will provide the correct wiring diagram and specify whether a neutral wire is required. Always prioritize safety and compliance with electrical codes during installation and consult with a qualified electrician if you have any doubts or questions. Always energize the circuit before working on any electrical equipment. Use appropriate personal protective equipment such as gloves and safety glasses. Inspect the wiring and components for any signs of damage before installation. Follow the manufacturer's instructions and wiring diagrams carefully. Ensure that all connections are tight and secure. Ground the fixture properly. Test the installation after completion to ensure that it is working correctly. Understanding the basics of electrical circuits is crucial for working safely and effectively with electrical equipment. An electrical circuit is a closed loop that allows electrical current to flow from a power source to a load and back. The basic components of an electrical circuit are a power source, a conductor, a load, and a switch. The power source provides the electrical energy that drives the circuit. Common power sources include batteries, generators, and the electrical grid. The conductor provides a path for the current to flow from the power source to the load. Conductors are typically made of metal, such as copper or aluminum, which have low resistance to the flow of electricity. The load is the device or component that uses the electrical energy to perform a task. Common loads include light bulbs, motors, and heaters. The switch is used to open and close the circuit, allowing or preventing the flow of current. When the switch is closed, the circuit is complete and current can flow. When the switch is open, the circuit is broken and current cannot flow. There are two main types of electrical circuits: series circuits and parallel circuits. In a series circuit, the components are connected in a single path, so the current flows through each component in turn. If one component in a series circuit fails, the entire circuit is broken and no current can flow. In a parallel circuit, the components are connected in multiple paths, so the current can flow through each component independently. If one component in a parallel circuit fails, the other components can continue to operate. Ohm's law is a fundamental principle that describes the relationship between voltage, current, and resistance in an electrical circuit. Ohm's law states that the voltage across a conductor is directly proportional to the current flowing through it and the resistance of the conductor. The formula for Ohm's law is voltage equals current times resistance, or volts equals amps times ohms. Power is the rate at which electrical energy is used or dissipated in a circuit. Power is measured in watts. The formula for power is power equals voltage times current, or watts equals volts times amps. Electrical safety is paramount when working with electrical equipment. Always follow these safety precautions. To energize the circuit before working on any electrical equipment, use appropriate personal protective equipment, such as gloves and safety glasses. Inspect the wiring and components for any signs of damage before installation. Follow the manufacturer's instructions and wiring diagrams carefully. Ensure that all connections are tight and secure. Ground the fixture properly. Test the installation after completion to ensure that it is working correctly. Electrical codes and regulations are designed to ensure the safety of people and property. These codes specify the requirements for wiring, grounding, and overcurrent protection. The National Electrical Code, or NEC, is the most widely adopted electrical code in the United States. The NEC is updated every 3 years and provides comprehensive guidelines for electrical installations. Local electrical codes may also apply. It is important to consult with a qualified electrician to ensure compliance with all applicable codes. Different voltages, such as 120 volts, 208 volts, 240 volts, 277 volts, and 480 volts, are used in electrical systems for different purposes. 120 volts is the standard voltage for residential lighting and small appliance circuits. 208 volts is commonly used in commercial buildings for three-phase power distribution. 240 volts is used for larger appliances, such as electric stoves and dryers. 277 volts is used for lighting in commercial buildings. 480 volts is used for large motors and industrial equipment. The choice of voltage depends on the power requirements of the load and the distribution system. High voltages are more efficient for transmitting power over long distances. Wiring methods and materials also play a crucial role in ensuring safe and reliable electrical installations. Common wiring methods include non-metallic sheath cable, or NM cable, also known as Romex, electrical metallic tubing, or IM, rigid metal conduit, or RMC, and flexible metal conduit, or FMC. NM cable is commonly used for residential wiring. EMT is used for commercial and industrial wiring. RMC is used for hazardous locations and underground installations. FMC is used for connecting equipment that may vibrate or move. Common wiring materials include copper and aluminum. Copper is the preferred material for most applications due to its high conductivity and corrosion resistance. Aluminum is less expensive than copper but has lower conductivity and is more prone to corrosion. Overcurrent protection devices, such as circuit breakers and fuses, are essential for protecting electrical circuits from overloads and short circuits. A circuit breaker is a device that automatically interrupts the flow of current when it exceeds a certain level. A fuse is a device that contains a fusible link that melts and breaks the circuit when the current exceeds a certain level. Circuit breakers are resettable, while fuses must be replaced after they blow. The size of the circuit breaker or fuse must be matched to the ampacity of the circuit. The ampacity of a circuit is the maximum amount of current that it can safely carry. The NEC provides tables that specify the ampacity of different types of conductors. Grounding and bonding are critical for electrical safety. Grounding provides a path for fault current to flow back to the source in the event of a short circuit. Bonding connects all metal parts of the electrical system together to create a low impedance path for fault current. Grounding and bonding help to prevent electrical shock and reduce the risk of fire. Lighting control systems are used to control the lighting in buildings and other spaces. Common types of lighting control systems include switches, dimmers, occupancy sensors, and daylight sensors. Switches are used to turn lights on and off. Dimmers are used to adjust the brightness of lights. Occupancy sensors turn lights on when someone enters a space and off when no one is present. Daylight sensors adjust the brightness of lights based on the amount of natural light available. Emergency lighting is required in many buildings to provide illumination during power outages. Emergency lighting systems typically consist of battery-powered lights that automatically turn on when the power goes out. Emergency lighting is essential for ensuring the safety of occupants during emergencies. Regular maintenance and inspection of electrical systems are important for ensuring their continued safe and reliable operation. Maintenance tasks include inspecting wiring and components for damage, tightening connections, and testing overcurrent protection devices. Inspections should be performed by qualified electricians. These are some of the key concepts and practices related to electrical systems. A thorough understanding of these topics is essential for working safely and effectively with electrical equipment. Remember to always prioritize safety and consult with qualified professionals when needed. Understanding the specific requirements for low-bay lighting with quartz restrike lamps, including voltage, wiring, and grounding, is crucial for ensuring a safe and effective installation. Always refer to the manufacturer's instructions and consult with a qualified electrician if you have any questions or concerns.